In this we're going to be talking about using logs to solve. On this very first equation, I think this one's pretty easy. You probably would know how to handle it, but it's worth reminding you of just kind of the rules of logs. When I take the log of something, it drops the exponent out front, so it would look like this: x multiplied by the log of 5 equals the log of 100. And of course, in doing that, we've created a multiplication. So now we could just divide to solve for x, and that's what we do. Divide both sides by log 5. So you could type that in your calculator, but that's the answer. The log of 100 divided by the log 5. And remember, you could also use the natural log. As long as you're consistent in what you use and what base you use, you can use either one. I usually use the natural log. Coming over to the next problem, the first step is to add 10 to both sides. The next step is going to be to divide by 3. Let me just remind you that 3 multiplied by 2 to the x is not 6 to the x. Things that are exponential, like 2 to the x, do not mix with things that are not, like 3. And I think a lot of times people think, well, when x is 1, 3 times 2 to the first, that's the same as 6 to the first. But that is the one and only time those two functions are the same. So we have to divide both sides by 3. And we take the log of both sides. We're going to end up, I'm going to use natural log this time. Natural log of 523 divided by 3. And divided by the natural log of 2. There it is. Next, coming down to condensing, a couple rules to remember. First of all, when two logs are being added, we're going to multiply their innards. But the first thing we should always do is look at coefficients. Remember, a coefficient comes up and becomes a power. And that's really just the same rule we used up here when we dropped the x down out front. The log of x log of 5 is the same as log of 5 to the x. So let me rewrite this. We've got the log of 5x plus the log of 2 to the third, which is 8. And as I said, because of the addition, we're going to multiply. So we're going to end up with log 5x multiplied by 8 is 40x. When we're subtracting logs, we divide. So 36 divided by 9, this becomes the log of 4. Now these rules should have been proven for you in pre-calc, and they really are just a restatement of the exponent rules. And I'm not going to get into it too much, but remember, in exponents, when you are multiplying, for instance, something like x squared multiplied by x to the 4th, that's x to the 6th. See, so when you're multiplying, and it's really just the opposite rule up here. When you're adding, you multiply. So they really are just inverses of one another, and as I said, you should have seen that before. A couple more things to remember when you're dealing with logs. In this case, I want to solve for y. I need to get rid of the natural log. And the way we do that is by taking e to the power of everything. Now remembering that e and natural log are inverses of one another. And in inverses, when you put a value in, to do the function, you get a new value. You put the new value into the inverse, it brings you right back to where you started. So e to the natural log of y is simply y. And the other side, I'm just going to rewrite right now as e to the natural log of 4x plus x. But I can do some simplifying there as well. I'd have e to the natural log of 4x multiplied by e to the x, using those same rules we just talked about, where when you multiply two things, you add their exponents. So here's 4x plus x. Well, again, e to the natural log cancels out, so we're left with e or I'm sorry, just 4x e to the x. And that's our final answer. Now there's one other problem. 5 to the x plus 5 to the negative x equals x. We have to use logs, but we're going to take some time to get to it. The first thing we need to do, bear with me because this seems strange, is we're going to multiply everything by 5 to the x. 5 to the x multiplied by 5 to the x is 5 to the x squared. Okay. 5 to the x multiplied by 5 to the negative x is actually 1. And if you're wondering how that happens, 5 to the x multiplied by 5 to the negative x, remember 5 to the negative x is the same as 1 over 5 to the x. Well, 5 to the x multiplied by 1 over 5 to the x is 1. On the other side, there's not much we can do, so I'm just going to leave it as 8 5 to the x. Like that. Now I'm going to get everything on the same side, so I'm going to have 5 to the x squared minus 8 times 5 to the x plus 1 equals 0. And at this point, it starts to look a little familiar. And I'm going to take all of those 5 to the x's and replace it with a different variable. I'm just going to, every time I see it, I'm going to write a u. Okay? That's kind of my key. So I'm going to have u squared minus 8u plus 1 equals 0. Well, now I could either use quadratic formula or completing the square. Let me complete the square. So u squared minus 8u over room plus 1 equals 0. Well, to complete the square, I take half of the middle, so negative 4, and square it. I'm going to put that right here, so plus 16. Now I'm not allowed to just add 16 and shift a function up unless I also subtract 16 off the end. So this whole thing condenses to be u minus 4 squared minus 15 equals 0. And now I'm going to solve for u. So u minus 4 squared equals 15. Square root, so u minus 4 equals plus or minus the square root of 15. So u equals plus 4 plus or minus the square root of 15. Now, of course, we're not quite done yet because we want to solve for x, right? We want to solve for x all the way along, and we now know what u is equal to. So I'm just going to run right back up here and use my little key and say, well, I know what u is equal to now, so I'm going to set 5 to the x equal to that. Natural log both sides. Divide natural log of 5. And there is my answer. One last thing. You might just want to pay attention to the fact that since the square root of 15 is less than 4, 4 minus that number is positive, so we can take the natural log. If this were 20, I couldn't take the natural log. This signifies I have two answers, but it's very possible if what's under the square root is too big that I only have one answer.